The PDF one was allowing you to take a bunch of data and throwing it into your L2 to create a histogram. That was the advantage of the Bino PDF. When you did the Bino PDF, if you had, I'm trying to remember an example. Oh, it would have been 10.6, that's why. Remember when we did all this, and you had to type it all together? When we first did all that, you'd create your L1, L2, and then we made the histogram. What Bino PDF does is that it will do all 7 of these calculations at one time, and then it will send it to your L2. We didn't really need to worry about Bino PDF except for really, in all honesty, one problem now that I can think, there's only one problem I can think of, is the puppy expected, which one would be the most expected male or female given those parameters. Remember that question on the worksheet?
Yeah.
That would be the only time that I would ever bother looking at a Bino PDF value. I wouldn't even have to put it in my table, because if I do Bino PDF, it'll put it in a list right there, and I can just scroll through to figure out which value is the biggest, and then just count was at 0, 1, 2, 3, or however it goes up to. Okay. Bino PDF was before I figured out what Bino CDF meant.
So PDF's not really.
PDF is not as relevant, except if you wanted to look at which. Yeah, you want to look at puppies. Sorry, you know what I mean?
So for a test, if it's a puppy question.
Well, if I put kittens.
Okay. So in that circumstance, only would you use that.
They're really the only time, and guys, just want everybody to hear this. Really the only time that I'm going to bother with a Bino PDF, not puppies, it could be anything, is when I'm looking at it, which one of these gives me the highest percentage? What K value gives me the biggest percentage, okay? Does that make sense?
Yeah.
When you have the, let me pull that up. Give me 1 second, guys.
You should always be one of the middle ones.
You can mess, yeah, absolutely. If you want to mess around with it, that's fine. That was 12.5, right? Yeah. 12.6.
There you go.
Here's a puppy. In this question here, in this first part of this question, it said on 14, it says, because the owner of the dog can expect to get more money for a male, what is the most likely number of males in the litter? This is the time that I would use Bino PDF, because if I do that, it'd be, let's see, Bino PDF. I have an N value of 11, comma, 0.5 is my probability, and then Bino PDF was just 2 values. That's right. It was just the 2 values. So if in our calculator, sorry, I had to restart my whole calculator again. That was the day before death. Yes, sir.
Why couldn't you just say like 50% of 11?
Because it doesn't always work that way.
How do you put it?
Those problems, like what like wording is it that makes it like final PDF?
I'm showing it right now. And that's, like I said, it's when you're looking at which one gives you the biggest percentage out of a whole list, instead of doing it all out. Yeah.
So like what numbers do you put in it and what?
N percent close parentheses. Because it's just 2 values.
These are really small.
So we have percent bears up.
Yeah.
Because I think the X value for trials, we're doing all 11 of them. These are 11 puppies.
Is the 3 value?
Wait, did you do?
No, because what did the PDF?
You got the same exact thing as what I got on that.
No. I'm backwards in it then. The PDF, we use the PDF to send it.
Wait, did you do this on Thursday all last week?
No.
I guess we've been doing CDF.
Like we never like
Are they all the same?
Oh, I had too many values. Why is it not doing it on my calculator? On mine on here, it doesn't work, but if I do it on this one, it should. Stat,
You get one to my.
or excuse me, second bars, Vital PDF. What did we say it was? Number of trials of 11, and we want comma point, what was our percentage, 0.5?
And then that's it? Both ones?
Yeah, because now, if you close the parenthesis out,
it's fine.
on my, you look at that,
I get exactly
Right.
what you're saying.
we're gonna have to take that, and unfortunately, we have to send that to the list, because it's not letting you scroll through it, okay?
No,
So
if you go off of it, I think you can scroll. What the heck? I was
Yeah, see,
able to
mine's,
scroll through it.
yeah, mine's not letting me do that. Is yours doing it?
Right.
I was just able to do it, now I'm not anymore.
How do you send this to me?
Oh, yeah, once you hit enter, then you just scroll over, so then you just kind of move it over.
It's not letting me.
So the third one, I have it, the third one is at .02, the fourth one is .08, the fifth one is at .16, the
Oh, yeah.
sixth one is .22, oh, .2255, and then it's .2255.
And what are these, what's
What these are telling you that, which value is going to give you the most outcomes. What this is telling you that between 5 or 6 males is basically what this is saying in this case. You have the best possibility of 5, or your biggest percentage of males in 11 litter is 5 or 6, because it wound up being the same percentage.
So I just
0.225.
multiply 11 by 0.5.
It doesn't always work that way. It's
Point.
it's because it's 50%.
Is there gonna be a question?
I don't know, I'm not done with it.
What does 4.88
That just happened to be the first value. This one,
So,
So you're going to scroll over.
let me change this here. This should work now. All right, this is what yours looks like. If you scroll, this is at 0 males.
Okay.
There's 1 male.
Oh, I understand.
See what I'm saying?
Yeah.
Here's 2 males.
Wait, did you count the first one as one?
That's counted at 0.
Oh.
Remember, because you have 0 male, to go on. Then we're at the third, and so on and so forth. That's what you're counting through, okay?
So you're looking for the same decimal?
No, you're looking for the biggest decimal you get.
And it just has to be the same.
And keep in mind. Sorry.
You get to this. Now just scroll right away.
Wait, what is that?
I just press right away. So when you hit final, you get
Yeah,
this.
you can't like move it down or.
You can't touch anything except right.
Yeah,
Yeah, Izzy?
So I think on Sunday I was trying to clear a list and then deleted like
So
two.
that's 15.
Having a discussion. Like I have my calculations list one
No,
list
so
two
you
list
said
five.
5.
Oh, just reset. Second memory 712 plus 712. Second plus 722. So that's what I'm looking at. That's the only time that I can think of ever having used a PDF value. It's kind of a pain. Okay, it really is.
So at 15, you just go to 7, that's your percent.
Yeah, and then this one, then you're looking at probability at least 7. That's when you use CDF because you're accumulating it.
Oh,
Because you want at least
You can't just
7.
like scroll over to 7.
No, because look at this. What it means at least 7. So you want it, your K value to be greater than or equal to 7. So you have to use a cumulative distribution function for 1 minus PDF to 6, or so CDF to 6, and that gives you the other side. Yes, ma'am.
Is there a way to like clear a whole list?
Yes. Second memory 4, I believe,
Yeah.
and then hit enter.
Oh.
Okay, and it should reset it. Did it reset it, Izzy?
Oh, well mine's already reset. I know I didn't reset.
What's that? Then you hit store, and then second 2.
Yeah.
Stove. Oh, sorry.
You've already done it.
Stove.
You've already done it.
Yeah, I ended up on that.
Oh, but we got to, I actually bumped the button, so once you get your your answer, then you vote.
Are you done?
Yes, I do. Grace, you're in trouble. You found drugs in your locker.
What's up, Tuna?
Okay.
I like this class because you can take your teacher not on a serious basis. You love your teacher.
I don't know.
Somebody makes that kind of comment.
He could be teaching us the wrong stuff right now.
Probably.
Are you giving him ideas?
Remember, I got hit in the head this weekend, so I'm a little off kilter. What else did you want to look at from last night?
Oh, last time.
Because maybe just like do it on pleasant parties.
Be specific.
You guys are good.
Most of them were
No, I'm looking at last night. Talking about last night's homework. What do you got? Anything on those? Other than the variance between the CDF and actually calculating the standard deviation by hand, which is a pain. Too much rounding error.
I can just like show the probability at 24.
What's your opinion on the hardest thing of this year?
Oh. It's all calculator work.
Right. So this is where you say
Now-
plot twist, no calculator.
Guys, give me a sec here, okay? So, obviously, when you go through everything that we've done, the first things we did was just counting stuff. That was when you had factorial, or you were just pizza toppings, like we did on the quiz, that I don't think anybody got that wrong, all right? Just multiply your options together, okay? When you get into permutation versus combination, which one of those? Guys, can you please whisper? Thank you. When you have permutation versus combination, one of those, the order matters. Permutation. Permutation is used when you have, for example, like from the quiz, you had to select president, vice president, secretary, treasurer, things like that. Because the president isn't going to be the treasurer. The order in which they were placed matters. The order in which you run a race, the first through third, those order matters. Because it's either you win or you lose. Okay? Something like that. Whereas a combination, how many ways can you arrange? How many ways can it be selected? Okay? That kind of goes into the card problems. The card problems. You think about what you did on the quiz there. They were pure, what was it, like three of one kind, two of another.
Yeah.
All right. Well, if you had three of one kind and two of another, remember when you're dealing with if you had three of one kind and two of another, well, first thing you have to select is a kind. Okay. Whether it was a suit, it depended on how it's worded. Okay. What was the question? Where did you got your quiz in front of you?
Will those questions always be due to the cards?
Yeah, a lot of them. It's like, and it really didn't do anything else with you guys with that, did I?
But like say like on an, if there's a question like that on an ACT, would it be hard?
Yeah, usually. But this is the kind of stuff, though, when you get to the ACT, the combination permutation isn't going to be so much as complex as a card proposition. The complexity that I've ever seen on an ACT when it comes down to probability stuff is like probability of an ace or an 8. I mean, it's simple probability. It doesn't get into this stuff as much. Okay. Yes, ma'am.
Okay, so when you say like three of one kind, do you mean soup or like
Can we do this one?
Number.
you mean when it's kind?
When it's kind, because then it'll say, because otherwise it'll say specifically this suit. Now, this was a question from the quiz. Okay. Three of a kind. Three of a kind means you have three of the same cards. Okay. So you have 3 4s and 2 6s.
So to choose one of them, if you 13 choose one.
Correct. You have 13, choose one, so you pick a.
4 choose 3.
Then it's 4, choose 3. Very good.
12, and then of another kind.
Of another
And
kind.
then 12 choose 1.
And
2 choose
4 choose 2.
4. 4 choose 2. Okay.
And then you go to the next problem.
The kinds just kind of throw me off
It's because you guys are, your generation didn't play cards.
I did.
Well, you don't understand it then. Did you tell me you got that question right?
I got it.
I'm pretty sure I got it.
Good question. Why do we have the 4 choose 3? Well, the first thing here is you pick a card. The next one is you want 3 of them. So let's say the first card.
Where did the fourth one come?
Remember, there's 4 of each card. So let's say you pick a card. Visuals.
Yeah.
I was confused with.
And I think they're saying 3 of them.
I can go.
No. All right, pick a card. Ready? Here's your card. What is it? No, it's an 8 of diamonds. So you pick the card. You want an 8. So you want 3 8s. So you picked your card. Now you're gonna get 3 8s. Well, how many 8s are in that card? So you want 3 of them. Yeah. So you've got 3 of them. Now pick another card. No, it's a 5 of diamonds, and you want 2 of them. So basically what you're doing is you're looking at how many different ways you can get a full house. There are 13 cards. If you pick a card, you want 3 of them. There's yes, there's 13 of the 8s. I'm sorry. There's 13 of the suit. Pick the card. You want 3 of that card. There's 12 other cards left over. You want 2 of them. What you're creating here is what's called a full house. A full house is 3 of one kind and 2 of another.
Why do you
Guys.
take away?
Because since there's only going to be 4 cards, if I have 3 of them, is there any possible way I can get 2 more of that same kind? That's why. It's kind of like a dependent probability, if you will, without knowing that you're doing dependent stuff yet. Does that make sense? Which one?
Exactly 3 spades of hearts?
3 spades and, yeah, it's pretty similar. The 3 spades and 2 hearts, it's just going the other direction. If you're doing 3 spades and 2 hearts, well, first thing, you want exactly 3 spades and 2 hearts. Well, the first thing you have, yeah, there are 4 there are 4 suits. You want to choose one of them. You want to choose the spades. There's 4. Choose one. Of those cards, there are 13. You want to choose 3. Now you got to go to the other suit. There are 3 suits left. You choose one. And of those 13 cards, how many do you want to pick? 2. That's a lot of complexity for a real garbage hand.
Say if what how skewed would it all be? Say if somebody brought in an extra card, like they brought in another 8 spades.
And cheated?
Yeah.
I have no idea.
So how would you do that? Say if the person wanted to get all aces and they didn't think that they would get an ace, so they brought in another ace.
They probably wouldn't last very long on that. They probably get shot.
No, but say would you have to?
I don't know. I don't know. Don't even worry about it. Okay, ladies first.
This is a really stupid question, but for this one, when you get the answer, would it be 1 out of the?
No, it's just, the question is, how many hands are there? It's not the probabilities, how many hands are there? In a deck of cards, how many hands are there? Well, there's a boatload of hands that have 3 spades and 2 hearts. There's a boatload of hands that have 3 of a kind and 2 of a kind. That's all that means. It's not the probability of getting that, because the probability of getting a specific hand in poker, a five card draw, is because remember we had 2.6 million-ish total hands?
Yeah.
So that's why. Yeah. Michael, what were you saying about?
Why do the 4 2s
Pick it, because there are 4 suits. I'm picking one of the suits. It has to be the spade.
Oh,
Okay? That's all I'm looking at.
Can we go over what you kind of coefficient of a term, but you're not for the classical triangle, but not the whole thing?
Right. All you're looking at is just the number in front of it. A lot of you guys, when you did that on the quiz, you forgot and you put the whole term itself as opposed to the coefficient. So if you're looking at, I know what you're looking at number 8. So it's the coefficient of the x squared, x to the 6th term of x plus 3 to the 10th. Remember, these things are always going to work out. It's going to be 10 choose something. We don't know what that something is, but I know that my first term has to be the 6th power, which means that my second term has to be raised to what power?
4th power.
The 4th power, and then this goes to be a 4. So all you do is you do a 10 choose 4, and then whatever it is, it's 3 to the 4, multiply them together, and there's your coefficient.
Oh, so you subtract the 6 from the, yeah, okay.
No, not subtracting.
I'm-
What I'm doing here is, oh, I see what you're saying, because this was a 10, this is a 6. Yes, that has to be a 4. Okay, I'm sorry. I was about to think you were doing something. Sorry.
Could you do 9? Like, what was 9?
Yeah.
9 was the whole thing. You guys screwed up because you did -1 to the 4th power, and you got -1 because you didn't put parentheses around it.
No, but like, what's with the 2?
What's with the 2? Well,
Because like,
isn't it going to be, it's 2x to the 5th? Because 2x is the first part of the term. So you have to actually raise 2 to the 5th power. Oh, yeah.
Are we keeping the home?
I got it.
Yeah, you might as well. Yes, ma'am.
And since that it would just be
Yeah, because -1 to the 4th power is positive. A lot of people wrote negatives in difference. All right. Now, yeah, it's all at 12. The other stuff I was going to say is I was going through some looking at some of the problem things here in 12, and let me pull this up.
There will be nothing about the lottery, right?
Oh, I don't know.
What? Okay.
When I was going through when I was going through a lot of the chapter review, the chapter test stuff, as far as things to look at, think about the stuff that we did. Did we just press buttons to find these ever? No. I didn't give you like, hey, what's 6p6? You know, that was
It's 720.
Wait, what? Thank you. 720. We did the binomial things. We wrote these things out.
Wait, how do you write out the p's? Is that the exclamation point with n minus r times n?
That was the other one. But you had a calculator.
For that part, you get a calculator?
I'm not taking a calculator from
No,
you.
I mean like, so how do you do the p ones then?
You press a button on your
I thought
calculator.
you said we never did it like that.
Well, yeah, I didn't just have you do the press a button. I mean, I could train anybody to press a button.
How do we do it?
gave us the word called.
Oh,
He's not gonna just
It's
change
permutation. Permutation. Remember, is the order matters.
Oh,
So,
okay.
you know, in a zip code, does the order matter in a zip code?
No.
Yeah. Last time I checked, you want your mail to go to your house, not like your grandma's house.
I was thinking, never mind. We think we're after everything?
Okay. Same thing with, you know, standing in the line at cafeteria. You're either going to get that last Twinkie, or you're not going to get the last Twinkie.
Order matters.
Yeah, it's just 4 factorial.
When do we use P and when do we use C?
Which one order matters?
Permutation matters, order matters.
Permutation, order matters, combination.
Order matters.
it does.
Not that
But
Twinkie, you better
with
do this.
It depends on the problem. I basically, let me just say this. There's no lottery, okay? So quit worrying about it, because I understand you guys aren't 18, you don't know the lottery.
Like, yeah, this question is gonna be about the lottery, but like, the lottery.
I'm not answering it, because I'm not talking about
The
it.
order matters years for the lottery, but yet when.
So when you go through the rest of it, and you start looking at the I've already said I'm not bothered with the lottery. You want to ask about the lottery, ask me later. I'm not dealing with
No,
lottery.
like,
Because you guys don't need to know, okay? You don't need to worry about it. You don't need to worry about it for tomorrow. So don't ask, okay? You don't worry about it right now, because I don't want to confuse everybody else. If you have a question, I will answer it later, okay? I promise you. I just don't want to confuse everybody else, okay? Okay? No, I'm just saying, I don't mind you asking, I just don't want to confuse everybody else. That's all, that's why I'm trying to stop you, that's all. Okay? You get into the probability, we did the real simple shaded region stuff. The area is shaded divided by the whole area. Yes, ma'am?
So back to the permutation stuff, if you were to say like there's 10 people running for 4 spots on the president, vice president, how do you set that up?
There's two ways of going about it. If there's 10 people running for 4 spots, how many ways can they be selected? That's a combination. If it's 10 people for 4 spots that are specific, that would be permutation. That would be 10p4. That's all it is. Press a button on your calculator. And if it was a combination, it's just like how many different ways can they be arranged? That's a 10c4.
The one where you had like 10 exclamation point over like 4 exclamation point, how do you do that? Because that was, I think, something
Back to the factorial one.
it was like the
6 bikes in a row.
drop, no, it was like the drama club one, like it was like that, except you were like, okay, put 10 exclamation point over it, and then it was like over 4 exclamation point.
Well, there were like 6 parts.
Yeah.
And then when there had the picture that went with it. It wasn't on the quiz or anything.
No, it was an old homework one. Yeah, because that one, because you had, if you were playing the role of one part, you're not going to play the role of another part.
Right, but how do you set that up? Like, how did you get the 10?
Well, how many people there were versus how many roles there were.
Right.
So if there was 10 people, pick 6. It was just a 10p6. You don't have to do it by hand.
Yeah, that was long.
Okay.
That's just long form. Yeah, I'm not making you guys do this long form. There's no reason. I mean, you can if you want. I don't really care. It's
But
just,
that's how it is, it's not 10 over 4, right?
no. What it winds up being, it would be, it is 10 factorial over 4 factorial, 6 factorial. So things always simplify out. Because then that's why you just press a button.
Yeah.
When you get into the rest here, flipping coins, compound events, when you're working through those, your ands, your ors, is there an overlap in the middle? Can you, that was when you're looking at either naked math, which was ridiculously simple, or when you had the cards again. In this case, when you had, like, what's the probability of being a black card or a 6? Well, how many black cards are in a deck of cards? 26. How many 6s are there? How many of those are black?
24.
This is just pure probability of this or this. Now, when you're talking about with or without replacement is when we went into the answer carries real quick.
What was the difference between this and then like the P, the probability of B like slash A?
That was just another way of writing it. That was compound. Okay, I'm getting there. Okay, this is your compound of that stuff. When you're dealing with what you're looking at is when it's kind of like dependent upon.
So and is multiplying or is adding?
It depends. It's so easy to distinguish when you read it. Okay? If you're looking at what's the probability of flipping a single card and getting a jack or a king. Well, how many jacks are there?
4.
How many kings are there?
4.
What's 4 plus 4?
8.
Out of how many cards?
52.
52. Whereas if you're looking at what's the probability of getting a jack and a king,
0.
One card. 0, because you can't get a jack and a king at the same time. Okay? But you can get a jack and an ace. No, I'm sorry, not an ace. I'm thinking a diamond. I'm thinking, in my mind, I'm seeing a diamond, but I'm saying ace. So a jack and a jack and
I
a
was
ace.
joking, I was like, what?
Wait, is it?
All right, you see what I'm saying? Now, when you're looking at without replacement, when you start getting into stuff like that, it's what's the probability of getting in order a king, a queen, and a jack without replacement.
Okay, can you give me an example? Because you said not always, because I and or. Can you give me an example one where it's or, but you can multiply it with like and, where you could add.
I just gave the or with the adding.
But that, so like normally.
Is it there?
Yeah.
Why do I keep thinking that there's always something? I don't.
Because the only
I'm
one
trying to
that
think.
was the cards, because you can have two cards the same numbers, so like.
Right.
That's just.
I'm just trying, off the top of my head, I'm trying to think, I swear there's a way that it doesn't happen.
What happened?
But I don't remember off the top of my head here. I'm trying to think. We got?
Okay, so if this one can say like, what's the probability of getting a jack or an ace
Mhm.
or 82 times what, or
It's plus, he's only picking one card,
so then plus
52. Because you're just picking one. Now, if you're picking consecutive cards, it'll say with or without
Yeah, and
replacement.
like, on the home
And that's
side-
a lot of times when you have to multiply out, because you're talking about independent draw. Independent draw is when you're multiplying stuff out.
Yeah, because it'd be like,
Because this is-
3, then an ace, and then a king or something.
Yeah, exactly, and you have to multiply those things through.
So if we were to multiply it with and then, like you get this, and then this, and.
Because you're looking at, because it's an independent event.
They just don't write down and because that's just.
Sometimes, yeah. Then after we did those, I mean, going back and looking at what you guys were actually working on, they weren't all that difficult. Normal distribution and binomial distribution is when you're using your those k values to success, working through the actual expected. What was the formula? It was the when you had.
Are you talking about like the UFO thing where you did like the.
Yeah, it was this one. Wrong one?
Some, whatever, whatever, and the probability, and the probability of not happening.
Yeah, I did not do anything on there where you had to worry about, is this a valid test? Remember we skipped over those. But remember when you looked at something like this where you had to randomly select the probability of guessing 5 questions right out of a 20 multiple choice question test?
Yeah.
Where you'd have to do those two different, your p-value, then you had the 1 minus p-value. We did a few of those. So if you have a 4-question test, what's the probability of guessing one of them right? Or not 4 questions, excuse me, 4 options.
0.25.
So your p-value would be 0.25, your n value is 30, your p-value 0.25, so therefore your 1 minus p-value is 0.75, and let's say your expected value, you want to guess, you only get 5 of them right. The probability of that happening would have been that 30, choose 5, 0.25 you want to get right, and then you want 0.75 you're going to get wrong. Never doing those. It's really fast and easy. We started to get into that with the less than and more than, and that's when we started turning things into the CDM. Right, when you get into those. Yes, ma'am.
Not relevant, but after this chapter, we still have one more, right?
Yeah, it shouldn't be that bad.
Probability that
Are we
it's-
gonna tackle all of that?
Right?
I don't know. However long it takes to get through it.
Okay.
To the negative.
We'll be done by the time you're done, you get to finals.
Alright.
Nice.
How's that for Nancy?
What is it
I
about?
was just
Math.
wondering,
Then it'll be on the finals.
What's that?
I was just wondering if you're doing one chapter or not. Alright.
Yeah, because we were trying, there's technically other stuff we're supposed to get done, but there's no way that we're gonna get all of that. So that's why I talked with Ms. Stenny and Mr. Fontana about some of the things that they would like you guys to see prior to pre-cal and its matrices, so I want to get into that. Yes, sir.
Actually, I'll wait till you're done, because it was on, I was just gonna like show you that.
No, what do you got?
Well, I was just wondering, it was like that area of this on the quiz.
Yeah.
Do you do the entire thing
Yeah.
minus that over the entire?
Yeah, the area on this one here, you've got the one circle gives you a total diameter of 23 when you add them all together. Okay. Your radius becomes 11.5. So your big circle that's shaded gets you 11.5 squared pi. Then you have to subtract out, well, I've got 1 circle, 2 circles, and a triangle. The larger of the 2 circles is an 8 squared pi. The smaller of the two circles has a radius of 2.5 because the diameter was 5. So it's a 2.5 squared pi. And then plus I had to do the area of a triangle, which is a 1/2 base in height, which they gave me both. So a 1/2, 7, and an 8.5. So when I have all this nastiness here, I'm probably going to figure out just 11.5 squared, put a pi next to it, and then I'm going to do all this in my calculator, and try not to do all of it at once because I'll screw it up. And then when I have it over something with a pi value, when I divide it out, you have to put parentheses around the pi. Okay? Yes, sir. Otherwise, you're dividing by whatever 11.5 squared is, and then you're going to multiply it by pi, because that's what the calculator thinks you're doing. Okay? You have to have parentheses around it. You have to have parentheses. Sir?
If the shaded area was the circle and the triangle, would you just eliminate the 11.5 squared pi up the top?
Yes, sir.
All right.
Yeah. Yep. Because it wasn't shaded. That's exactly right.
But so you don't want to multiply 11.5 squared times pi?
No, what we're saying here, Ben, is that in the calculator, when you get this answer, when you hit divide by, you have to do this. You got to put that bottom part in parentheses, otherwise it's screwed up, unless you use a fraction. But if you remember, whenever you have a pi value in your denominator and you're using the calculator, close it off in parentheses so you don't mess it up. Yes, ma'am.
Do you want us to keep, like, say, if there was an x value, do you want to keep it in root form?
Oh, I don't care. I really don't. To be honest, it's a lot of the hex kind of stuff. We're talking about area, the probability. You're not going to have a root in probability, so your probability is going to be less than 1. Okay, so you're going to be using that source. Like I said, I would just kind of putz through this chapter review stuff. They're pretty simple. Again, they're showing you how that calculation of the standard deviation works within norm distribution. If you just want to use the approximation of values that we're doing with the CDF, you're fine. It's not a big deal. They have a couple of nice problems here where they're talking about between 87 and 93. Remember what your calculator is doing when you do that. If you're doing a CDF value and you want to get the expected between 93 and 87, you have to get the expected CDF of the 93 and then subtract the expected of 87. But be careful. If it says between 87 and 93, does it include 87 and 93? No, it doesn't.
So do 92 and 88, or?
It'd be 92 and 88. So then you have to remember, what does that mean in my calculator for CDF value? If I'm looking at the values be between 87 and 93, I think it went up to 100 and something. I don't remember, and this was down here at 0. If I want to find the value between here and here, it's saying between those two, it's not including, it's saying between. In my calculator, my CDF function, I would have 92, because it would start here as a person, and it's going to give me from 0 all the way up to 92. And then what would I set for my lower bound? 87. It would be at 87 because it'll give me from 0 to here, not including what's after it. Does that make sense? So be careful when you look at how it's worded. And that's the only trick that I can ever see with any of those CDF functions, is that reading via a number. Remember we talked about it yesterday, throw it on a number line, look at where it's being placed.
So if this is including 87 and 93, would it be?
Then it would just,
93 and 86.
yes. Because it's going to go up to 93, and then the other one, you're going to want to back everything out behind 87. So yes, we do that. What her question was is, if it said including 93 and 87, I would set it to be at 93 because it would count everything up including 93. Then I'd have to back out, if I wanted to include 87, I'd have to back out at 86. It's the only little weirdness of this. That's the only disadvantage of the CDF function, is knowing where some of those values go, as opposed to using the standard deviation that they set you up in the book.
And that's what you like to track down.
Yeah. Because you're looking at that middle boundary. All right. Remember normal curve stuff, you just got 68, 95, 99.7. Remember, I'm sure you can subtract and divide by 2, I hope, to get your other breakpoints. Those percentages never, ever, ever, never, never, ever, never, never change. It's just a matter of your averages and your standard deviations, what changes is plucking out. You saw that last night. It's probably pretty simple to work with. Okay. You can still do independent events that are based upon probability. How many times do you want to be within a specific section? 3 people, 4 people, whatever. You're not multiplying it by 4. You're using the 4th degree to do it 4 times. Okay. Oh, sorry. Still in on it. It's good times.